Gaussian elimination is the most useful way to solve a system of linear equations. Before we know how to start to solve it, we have some terminologies to note first. First of all, we have to present the system of equations into a matrix form, which is called Augmented Matrix. So the format of this Augmented Matrix is not very difficult, which is we copy the coefficients of x, y, z from the equations, that is 1, 1, 2, 3 minus 1 minus 1, and 1, 2 minus 3. Afterward, so we put a vertical line there because we are going to write the constant terms on the right-hand side, which are 6, minus 7, and 8. This is called Augmented Matrix. After writing the Augmented Matrix, we aim to simplify it into a format called Rho Echelon Form. So it should be Rho Echelon Form. So the format of this matrix will be in the form of, first of all, in the first row, we have 1 as the leading number with some numbers afterward, and of course we may still have a constant term at the end. Next, the second row should be 0 at first, 1 as the leading number, and some numbers afterward. So the last row should be 0, 0, and 1 on the Z column, and you have a number afterward. Next, take this Rho Echelon Form as example. After we obtain this Rho Echelon Form, the feature of it, you will see there is a 1, 1, 1 as the leading number in each of the row. And then if we consider the matrix into equation, you will see that actually the equations now it would be x plus y plus 2ez equal to 4, y plus ez 2ez equal to 5, and ez equal to 2. And you will see that the importance of Rho Echelon Form will be is telling you the answer for ez in the last row, which is 1ez is equal to 2. After that, then we can fall back to the previous equation and having y equal to 1 by simple substitution. And then lastly, you also can fall back to the previous equation having x plus 1 plus 2 times 2 equal to 4. That means x is equal to minus 1 finally. And now you can see the significance of Rho Echelon Form. In the last row, it helps you to read the answer of ez directly, in which the value of ez, which is a 2, can be falled back to the previous equation to get a y. And because the leading coefficient is 1, it's very easy to read the value of y afterward. And similarly, we can obtain the value of x. Next, we have to see how an augmented matrix to be changed into Rho Echelon Form. So there are 3 basic operations which we call they are elementary row operations. The operations including number 1, you can reconsider the position of rows, so we call interchanging rows. For example, you can change the position of row 1 and row 2 by the symbol with arrows at 2 ends. Next, we can consider multiplying a row by a k. For example, we can consider 3 times row 3 and then put it back to row 3. That means each number in row 3 will be multiplied by 3, and you change it into 3, 6, minus 9, and minus 24 respectively, if it's necessary. At last, we can also add a multiple of one row to another row. So what does that mean? It may be like, I want to cancel the 3 in the second row. So I minus 3 times row 3, which is a 1, and then so puts back the results into row 2. So next we will look at the example to see how these elementary row operations to be put in the augmented matrix. Now let's go deeply to see how a Gaussian elimination will be applied to solve this system of linear equations. So first of all, you have to check the first row whether it's starting from 1. So if it's alright, then now we are aiming to make these 2 numbers, 3 and 1, to be 0. So that's why we will be doing 2 operations. In order to cancel the 3, we will be having row 2, which is a 3 at first, minus 3 times row 1. And then so we put the results back to row 2. Okay, so let's see what does that mean. I keep row 1 unchanged. So we have 1, 1, 2, 6. So that's why for this number, you will have, okay, let's write clearly, 3 times row 1, that means 3 times 3, which gives you a 0. So while the second number should be minus 1 minus 3 times 1, so which is a minus 4. Next one, we have minus 1 minus 3 times 2, which is a negative 7. And finally, we have minus 7 minus 3 times 6, which is minus 25. So that's how we operate on the second row, by using the having row 2 minus 3 times row 1. After that, then we can also do the second operations at the same time. So that's why I will mark 1 and 2 here. Next, we are going to cancel the 1 here in the row 3. So that's why it can be simply as row 3 minus row 1. So and we put the results back to row 3. So that's why the first number is 1 minus 1, which gives you a 0. Very simple job. 2 minus 1, then you have not 0. This is 1 here. Next, you have minus 3 minus 2, which gives you a negative 5. At last is minus 8 minus 6, which gives you a minus 14. So that completes the first two row operations here. So each of them I'm using adding a multiple or subtracting a multiple of one row to another row. So but the main point would be we want to make zeros in the second row and the third row. Coming up next, then we will be seeing that we want to have another 1 in the second row. So that's why I will be going to change the position of row 2 and row 3 by writing the symbol as follows. So we say row 2 change with row 3. So it gives you 1, 1, 2, 6, first row, no change, while the other two row becomes 0, 1, minus 5, minus 20, not 20, minus 14, and 0, minus 4, minus 7, and minus 25. So this is another change of the augmented matrix. Finally, we want to make 0 in this third row. So that's why we are going to have row 3, but this time will be plus 4 times row 2, because there's a 1 on top. And then we put the results back to row 3 as follows. Now, so take a short while to complete the questions. Finally, it should be 0 and 0 as well, times 4, that means minus 20, you have minus 27. And finally, you have minus 81 here. So this is another operations. Next, so I'll put the answer on top. In the last row, you will see that it's minus 27. So that's why row 3 can be divided by minus 27. We put back the results to row 3 in order to complete the Rho Echelon Form. That means first row 1, 1, 2, 6, second row 0, 1, minus 5, minus 14, and the last one will be 0, 0, 1, and you have a fraction, not fraction, it's a 3 finally. So the end of the question will be ending with 1, 1, 1, so as in the form of like staircase, or we call it echelon form. So it's not the end because Gaussian Elimination is assisting us to find the answer. So now you need to read the answer by yourselves. Put back to the equation form itself. Now we have x plus y plus 2ez equal to 6. Y minus 5ez equal to negative 14. And the most important start of the thing will be at last, ez will be a 3. So that's why then you can go back to the substitution where y minus 15 equal to minus 14, which gives you a 1 for y. Whereas x plus 1 and 2ez, that means it's 6 equal to 6, and x is a minus 1. So finally, we draw a conclusion. Now we solve the equation x, y, z to be minus 1, 1, and 3 respectively. Is it clear for you to see how we can operate Gaussian elimination? That's good.